1, 2, 3. SONM. Our next speaker, who is a specialist in computing science with 15 years in IT experience, including 7 years developing software for the enterprise.
Hello everyone, my name is Igor, I'm CTO of SONM, as has already been mentioned. So the SONM, this name was, we first invented this name, invented this, and then we finally invented how to translate it and to explain this. So this was first the SONM. Talking about our company, we do fog computing platform, that is, I will describe what it's doing later. We first need to understand what is fog computing, because this is the key to understanding what SONM is doing. Talking about me, I was working for 15 years with classic system architectures, the OLTP systems, the data warehouse, the OLAP and the BI systems. And what I have learned for these 15 years is that the old approaches, they just simply don't work anymore for many cases. They still work for some typical situations, but the new challenges that rise, they cannot be solved with classic architectures. So new things arise, and we'll try to understand this during my speech. So this is me. And what we have as a classic architecture, we have what is called free tier, the client-server architecture, where the server is split into the application server and the database. And this is what was something like a golden standard for 15 years, maybe 20 years. And I started learning in the university in 2002, and we were studying this architecture, and this was good. The Oracle database and the Microsoft SQL Server, they were fine for many cases, but at these times, there are challenges that are difficult to be solved by this approach. And what are the challenges? First is the increasing computing load. We simply cannot scale traditional databases in a vertical manner, because we have memory limitations, we have the limitations of how many CPUs we can plug into one single server chassis. So we cannot scale it upwards, so we need some other scaling method like horizontal scaling. Another challenge is the increasing storage amounts. Of course, we know that the disk capacity is increasing each year, but still the data amounts, they grow faster than the disks are growing. And we need some approach to work with this data, the big data, because not a single database, including Oracle or even Teradata or even the best solutions you may know, they cannot even try to hold everything that you possibly need. And big companies like Google, Yandex or whatever, who are caching the internet, they cannot simply use these databases, and for the long years they have been inventing their own solutions, and currently these solutions are going to the public and more companies are trying to use them. And another problems are the networking requirements increasing, because we still have the light of speed limitations, because the latency problem cannot be solved, and we live in the world where the concurrency rises and the latency is still the problem. We need to somehow reduce the time between the server response and what the client sees on his browser. And there is also a problem of the throughput of the network, because the amount of data on the edge of the network, the IoT devices, the data from sensors, other data, this amount is increasing. It's hard to transfer everything to the cloud. People are renting direct optic lines between traffic exchange points just to try to solve this, but still this is not working in any cases. So YouTube has to rent server racks directly in many service providers to serve the content from the place near the customers. So this is the challenges. What we see now, we are in the point of the time in the history where the previous architecture is at the end of its era. The free tier architecture, the golden standard, is going to the new architecture, which we can simply describe in two words: the microservices and the MPP. Microservices is a new approach. Yesterday we had a division in the servers. We had a functional division. We had a client, we had an application server, and we had a database. They were doing the different roles in the process of serving data. Database was the storage, and the application server was the execution point. And the microservices is approach when we split on the high level, we split the task by the domain, by the entities. And internally, each microservice can still be free tier or whatever architecture or key value. But on the top level, we now have different division. We now have more nodes, more computing nodes, more pieces. And this division is not functional anymore. This division is domain specific. This division is entity specific. And the MPP approach is a solution for databases that is still young, and there are not more good examples of working databases with MPP approach, but still we cannot use databases with old approach with SMP because none a single server chassis can hold all the SQL queries, so we need to somehow split the data amounts onto different nodes so that none a single node holds all the data, and we need to somehow split the search process with the methods like MapReduce and this kind of things. So finally, we are in the time of the transition from the old architecture to the new architecture, and this requires us to change the way how we write the software. So currently, a lot of people are writing microservices, and the Kubernetes is getting more popular, and Google is popularizing this approach so that people do it differently, so that everyone knows how this is done. This is a trend, you may already know this. The containers was a relatively new thing. In the terms of the enterprise, this is so young technology that it may not be even considered at this moment because it's just too young compared to the 10 or 20 years of the databases. But it is growing very fast, and a lot of people are already doing microservices. In the times before, this was the approach on the big companies because this requires different thinking, and this is a little bit more complicated to write microservices than to run a traditional database. Traditional databases helped you to develop your software very fast because you could just offload your tasks to a database, just write a simple SQL query with joins and hope that the database will somehow optimize it, somehow do it the right way. But now, if you are writing microservices, you have to think about yourself. The complexity of the development is rising, but at this moment we have a lot of working systems already, because 10 or 20 years ago there were few systems, few internet shops, few websites, so at that time we needed to speed up the development, but now we already have plenty of products, so now the priorities are different. We now need to scale this. So new era is about scaling, and keeping in mind the fact that people are writing microservices, what do we have? With microservices, we now have more computing nodes than before. Before we could have 2 free computing nodes. Now we may have 20 or 100 of computing nodes, and having that many nodes, the management process is increasingly becoming more difficult and more complicated, because even if you have the reliable hardware and reliable cloud provider, you have a probability of failure of a single node just because you have more nodes. This is a mathematical expectation rising. And at this moment, you need to start thinking about reliability and redundancy and replication on the side of your application. Because if you don't do this, you have the probability of failure because you have more nodes. So the trend, as we see it is going to that direction that people are writing the software in a new fashion, and they now have to think about reliability and redundancy on their side. Well, if we do that, to face the challenges, if we scale in the horizontal fashion, if we work with big data and use that approaches with MPP, we have from now on, we have different requirements to the hardware and to the cloud provider, because when we had a few computing nodes, we need the hardware to be completely reliable. We need it to be almost 100% reliable, because if a single database node fails, if an Oracle database goes down, your whole business will stop and you will lose millions of dollars. But if you have microservices, if you have 10 microservices totally, and each microservice is split into horizontal scaling fashion, and if it's replicated or self-replicated, and if you lose 1 or 2 nodes, you simply just don't notice it. It's just a common situation. You just add additional nodes and scale it and replicate the data. So at this point, we have a situation that we have different requirements. The requirements are reduced now. We have a lower requirements for computing nodes as we see it now, because you don't need really that enterprise-grade reliability. This is my point. The second point is that we have a technical possibility of running on multiple nodes. And we have that multiple nodes because a lot of people around the world, they have computers at home. There are different groups of them, just common people with computers with quite modern CPUs and GPUs. We have ex-crypto miners with heavy GPUs which are willing to solve some practical tasks. And we have excessive amounts of capacity at the data centers because they have excessive capacity just for the case if someone will buy in the next hour. And we have a motivation to move to some other architecture, to some more widespread architecture, because we would like to reduce costs, because we would like to scale. So we have all this all together. The technical possibility, the amount of nodes that are willing to serve this task, and we have the motivation to do this. So we come to the idea of the fog computing. What is it? Fog computing is a, of course, this is a buzzword that is used in the mass media, and there is no strict definition at this moment. And there is, for example, an open fog consortium that is trying to write requirements and to write a standard about what is fog computing. But as we see it now, fog computing is more of a software architecture. This is a way you write the software in a fashion that it can scale horizontally, in a fashion that it can more easily migrate to different nodes and just to occupy the living space of computing nodes, and in a fashion that it allows you to be more closer to the client, somewhere on the places, somewhere not in the data center but around the users, somewhere in the crowd. And why I say this is more about computing architecture is because this is not only about the hardware, this is not only about the virtual machines, this is more about how you write the software. You need to scale it, you need to replicate it on your own. So what are the benefits of fog computing for business? First is that your data is not stored in one single place anymore. You don't really have to build a data center in each country or each town, and neither you have that opportunity anyway. So now your data is living everywhere, near your customers, in each internet service provider. We have a trend that some tasks are more effectively solved on a specialized computing units like GPUs, because this is about the number, of course, because CPUs is a super powerful processor. It has very complicated logic, but it has few amount of cores. But GPU is simplified its RISC architecture. It has faster memory, and there's thousands of nodes. This is something like 100 times more powerful. Of course, this is just a relative amount, just a way of saying, but still on some tasks, GPUs are times more powerful than CPUs. And in fog computing, you may get access to that amount of GPU cores because people have a lot of GPUs on places, and still GPUs in the data centers are not so popular because just this is not a popular service that they provide. And what else about the fog computing for business is that it allows you to reduce the costs because the prices are lower. Why is it happening? This is happening because in the enterprise, in the data centers or in the cloud, you have enterprise warranty, you have enterprise grade hardware, you have 5-year warranty which adds just the double price to the equipment, and you have 5 years of warranty. This is so much, and this is really reliable to have 2 power sources. But if you had not 2 power sources but a single one, if you had a single internet line, that perhaps would be enough for your new microservice architecture, because you are ready to lose one node. Nothing bad will happen, you will just scale to the next node. So this is also about prices, and particularly about the prices on the GPUs, because we have a limited supply of GPUs, and currently the prices are so high on them because people are doing crypto mining with GPUs, and we have a strange situation with marketing that we have relatively similar computing nodes of the GPUs, but they are sold under different marketing brands to the enterprise and to the consumer grade. And these computer nodes for enterprise like Tesla or GeForce, they are relatively similar. The Tesla is having double precision, but double precision is not something that everyone needs. For some tasks, common precision is just fine. So the consumer-grade GPUs, they are 5 or 10 times cheaper than the enterprise options. But on some tasks, they show equivalent performance. And when you want to run your application on GPU, you have an option where do you get this GPU, and in the cloud you may get only the enterprise version. But people on the home, they are having consumer-grade GPUs, which are times cheaper, and they have lower costs on the maintenance, because you have an engineer each home who maintains his own PC. Perhaps he's not doing this as good as in the data center, but he still takes the dust off his PC, and he still pays for his internet line. And this works for many cases, as we see it. So what is SONM? As we talked, I tried to explain what is fog computing. So SONM is a platform for fog computing. Fog computing itself is more of the architecture of the application. So someone must write an application keeping in mind the fog computing, but SONM can provide resources that will perfectly complement what you write in the fog computing fashion, because you have computing nodes all over the planet. For the customers, for the people who run the application, this looks like essentially an infrastructure as a service. So you may deploy, you may rent an instance typically. You have an instance, you have a number of CPU, of memory, of disk, of network, and you have a tight term for which you rent this amount of resources. So you have a spot deal which is terminated at will at any point. And this is something that is relatively similar to what the cloud offers, but it completely differs on the back end. We don't have any data centers. Our network nodes completely distributed. This is a self-governed peer-to-peer system. And we have just one tier system, and this is open source software. We are a software development company that writes open source software, and you may install it, and your computing node will be part of the network, and you will be part of the SONM. This internally uses the blockchain name Ethereum for smart contracts to keep the consensus, because the distributed decentralized system requires a consensus mechanics. Just how do they agree what to do? And this agreement is based on the Ethereum smart contracts, and essentially the most critical part is placed there, the marketplace. And the marketplace is a mechanics of how we distribute the computing powers, because we have a lot of computing powers. We could contribute them to one single project or to 10 projects. How do we decide who will use the resources? The answer is just the economic answer. Who will pay for them? That person will use the resources. And so we have the marketplace as an essential piece of the system. You may buy resources just on an exchange. As a customer, you may rent an instance. As a supplier, you may get payment for renting out your PC. This is similar to what ARB, but for computers, or like Uber for computers. So as I mentioned, we have internally the marketplace. For the consumers, who are the consumers? We see them as software developers and IT companies, or companies that maintain or using the software for machine learning, rendering, content delivery networks, scientific calculations, and perhaps game servers, hosting, and perhaps cryptocurrency project as well could benefit from our system. So just two groups of people, consumers and the suppliers. And from the suppliers, we see, as I mentioned, three groups of people: the home users, the data centers with excessive capacity, and the ex-crypto miners. I name them as a special group because there are really a lot of them, and they have a lot of GPUs which could serve good work for machine learning and rendering. Again, our offer for the clients. For the clients, we're offering infrastructure as a service. So technically what it is about, you specify the resources you would like, and you manually rent out or buy out an instance. And then you may deploy Docker containers there. So the infrastructure as a service now works with Docker containers, and our work is towards developing a platform as a service. So we can scale automatically your application for you, but this would be the matter of the late year of the 2018. For the suppliers, as I mentioned, we SONM will rent out your computing power. SONM will rent out your CPU, your memory, your disk, your network, your everything. We will use your network to host relay servers for the people who don't have public IP address, so we can use your host as an intermediate server. We will rent out your CPU to solve some specific SONM tasks to maintain the SONM system, and we may use your CPU for CGI rendering or web hosting. We of course will use your GPU for the cases of machine learning and rendering, and we will use your disk for storages, so everything will be bought and rented out. And of course, we develop relations with possible technological partners. I will try to explain this. For example, there is a typical cloud stack which consists of the bare metal, and then the infrastructure as a service, and then the platform as a service, and then the software as a service with the different domains, and finally function as a service. So we are trying currently to think about the fog computing stack, and we see different solutions possible here. We need some storage solutions to help us complement our platform, and other things. So we attract companies and people who have their services to join us in our work for the future. So this is basically what I wanted to tell you. We have application online, so you can apply if you have some ideas or proposals or questions, and we will also have a meetup. Looks like it is today. And we already have a booth here in the conference and G45, so please visit us so we can tell you more about our system and perhaps even present you a sticker if you still have some. And so, well, I finished with what I wanted to tell. We have 9 more minutes for questions if someone has. I hope you have some questions. So, yes, please. Just wait, a microphone will arrive.
Hi. I very much like the concept. It's very interesting to see how you can use all the distributed compute power to join that together in Microsoft's architecture. I've thought about these things before, and always the question is what you do with network latency and the time to bring these typically like virtually big data sizes to the actual nodes. How do you solve the network problem and security in these kind of things?
You asked a couple of questions. First about the network. The short answer is we don't solve it. We just have all the capacity we have. We have computers which are at home. They have, of course, the limited network capacity, but we have computing powers from the data centers which have some more wider channels. And we just offer what we have. And for some tasks, this will be perfectly fine. So when you go to the marketplace of SONM, you specify what computing powers you need, and namely, you say what bandwidth do you need. And if you need 5 megabits per second or 10 gigabytes or gigabit, you'll just have an offer what's existing there at this moment. Perhaps if you would request 1 gigabyte, you will have only limited offers from data centers. So this depends on your application. We are planning to develop some service to check the network and to build the network graph, so we can see which nodes connect at which speed. And some nodes would be in the similar internet service provider on the internal peering, so they will have greater speeds. But this is still under work. Okay. Someone else? Perhaps about the blockchain? Perhaps about, something else? More for computing? Sorry? Yes, again, a microphone will reach you.
Again, I've spent some time thinking about these problems. I'm really curious about your take on this. The specific problem that when you run a particular application on a particular data set, the data set will need to be present on the physical hardware where this compute job is done. How do you provide security around tampering in the data? Of course, I understand that if you spread out the data everywhere, it's very likely that someone will get the actual data that is looking for, he'll get something. But for example, passwords or something. How do you prevent tampering of the data or inspecting of the data on the end user's machine?
Yeah, this is perhaps the most complicated problem of the project. You correctly foreseen this in what we do. So this is complicated in short, but we have some workarounds here and we have a stack of workarounds here. First step is that some projects do not require privacy. For example, if you are hosting public websites or delivering some kind of content, you simply perhaps don't care if you have 5 times lower price. Perhaps if you have the same price, you will still consider the privacy, but if you have an offer times cheaper, you will say, oh, okay, I don't care about this. And the second step is that you still require privacy, and the most projects, of course, require privacy. We have different suppliers. The part of the suppliers is computers at home, of course, which have problems with security because you simply don't know who they are. But we will have KYC for them, so you will know the person, because to contribute computing power, it would be possible to ask for KYC from the person. And we will have suppliers from the data centers. And the data centers is something that you typically trust, because when you work with cloud provider and you choose one, either from the top tier or some less known companies, you simply trust them their data. You just hope that they have firewall security policies and engineers in place just to close all the securities. And similar companies, just particularly the same data centers, they will sell excessive capacity to SONM. And if you require privacy, you may look for resources directly from them, selecting by name or from whom you trust. This is the second workaround. The third workaround is that some things could be solved on the side of the application. And I will give you an example, like Proton Mail. Proton Mail is something like Gmail, but done by the scientists, and they do encryption of the client. So the server nodes is simply not knowing what's going inside the letters. And you have 2 passwords, one from the account and another to decrypt the data in the browser directly. So the third workaround is that you can handle it on the application side or on your own hardware. Perhaps you will not host everything on SONM, of course you will not, but you may host some parts of the application there that are not critical. And if you have microservices, and if you have the whole data set distributed into single entities in each microservice, it's more easily to encrypt them and more easily to keep track of them because you have simpler data processing. And there are indeed some algorithms to do this, to process data without unencrypting it. There are some. They're complicated, of course, but still you may sort data without de-encrypting it. And finally, we are working on a hardware platform to solve this problem with Intel technology, with trusted platform module and secure boot and that kind of things. But this is currently a research. So we hope this would give us the result finally. So this is the workarounds. The monitor says that my time is up. So thank you.
Igor,
yeah.
Thank you so much. Igor Lebedev.